Well, thank you for inviting me. This has been a labor of love for me for the last 45 years. So some of my slides are old slides, and these infernal machines are very difficult for somebody as old as I am. So there'll be a few glitches here and there, and it won't be as polished as some of the new PowerPoint slides, but this is a pretty good representation of what we have here. I'll try this machine for a little while. If it doesn't work, we're going to go back to something else. So let's start by talking about the Pacific Northwest as it appeared 15 million years ago. That, let's see, where's the light? There. This is the Cascade Range, and it was there because all of the basalt that poured out later on filled up the basin, and it vented out through here and went into the Pacific Ocean. So there was a high ridge along there at that time. You'll read that there wasn't a ridge there, but I definitely believe there were some pretty good mountain ranges there. The Coast Range was not there, and the coast was right probably about in here, although there's some evidence that that might have been not true either. So about 18 million years ago, big fissures opened up in this area right here. This is called the Chief Joseph Dyke Swarm. And these fissures were cracks in the earth that went down to the mantle, and big fountains of basalt went probably all the way to Spokane, actually, from this area. You can still see some of these dikes down in bottom of the Grand Ronde River there at Brogan's Cafe. Right across from that, you'll see some of those dikes and that whole area through there that's been dissected by the Grand Ronde River shows these dikes. Now, most of the basalt went this direction and went out, and you can see it sort of goes right out through that little notch there, so maybe that Coast Range was there then too. But where it went into the east side, the north side, and the south side, it created lakes wherever it encountered a river. This is the whole stack of basalt, and 93% of it is right here. And that gave off a terrific amount of carbon dioxide. And it was probably a trigger of a warming period, in my opinion. There's a lot of people that say it wasn't. But this is the last time that the Earth has been warmer than it is now. And the Clarkia area is right up here. So that was probably at the maximum concentration of carbon dioxide at that time. Maybe on the way down. We don't know. We're working on that now. These are fossil sites that are associated with the Wanapum. Let's go back, and the Wanapum is this unit right here. These two flows are found in the area out there now. The one that caused the dam is the basalt of Rosalia. This Clarkia floras are associated with it. These are fossil sites. There's one here in Moscow. Do you remember when Sweet Avenue used to be a oil distributorship, and there's a lot of pollution went into Paradise Creek right through there? Well, when the university purchased that, they cleaned it up, and they dug a great big hole to get rid of all of the polluted material. And in the bottom of that hole was a diatomite that was full of Miocene fossils that were just almost exactly like the ones at Clarkia. Probably it could have been associated with the Grand Ronde basalt, but I think it was probably this one. There's also one at Pullman that's associated with Rosalia. Clarkia is right here, and this is the one we're going to concentrate on. Clarkia, the town of Clarkia is right here. Fernwood would be about here. Santa would be about here. And this is the point where you go up over the top of a ridge, across Flat Creek, and down to St. Mary's. So the dam, and you have driven out through that area, notice the road goes, Highway 3 goes right down through here. It's straight as a die. And the old St. Mary's River is exactly in the same place it is now at that time. It was dammed there, and it had a terrific variety of fossils, of trees growing around it. Not anything like today. This is the bedrock, and that has something to do with it. These are all old Precambrian rocks with the exception of this little one here. This one is a basalt, or a granite that's right on that pass between Beauville and Clarkia. But it was all ancient rock, and ancient rock doesn't have as much nutrients in it as the brand new basalt did. Most of those other fossil sites were on older basalt, much younger than the bedrock here. This whole story started in 1972 when Francis Kienbaum was building a snowmobile racetrack. And he plowed into the night after this picture was taken. He plowed the end off of this little hill here. And when he came out the next morning, there were big blocks of material around with leaves all over, and he found a fossil fish, much like this one. This is a member of the minnow family, the dace and what used to be called squawfish, which are now called pike minnows. They're in that family. And he thought that was important, so he called the university, and Jack Smiley, who was the paleobotanist here, or is a paleontologist, the only paleontologist, but he was a paleobotanist. And he thought this was one of the greatest things in the world when he saw slabs of rocks like this. This is pretty fantastic. This is a tulip tree here. I'm going to use the common names and the scientific names as I can remember. So let's stay with the common names for a while, and if I stray off, call me on it, please. This is a chestnut. This is a Tupelo, sweet gum, oak, bald cypress, another bald cypress. There's another sweet gum right up here. This is a typical slab. This isn't rare. And many times we find fossil sites where there'll be a mat of leaves and you can't tell one from the other, but it's almost like this thing was laid out so you could actually see each individual leaf. I have some up here that we can split after my talk, and I'll show you what I mean about that. Anyway, this is what the site looked like after Francis got through making the oval for his snowmobile racetrack. It's now a motocross racetrack, so it doesn't have an oval anymore. It's got a lot of dips and dives in it, but Francis died about 7 years ago, and his son still runs the track and is very cooperative. The university has an agreement with him where they allow field trips and research to be done at his site. I own another site just like this that I was able to acquire, and I moved a house on it, so my house is 15 feet in front of my research area now. This is a picture of a birch leaf, and I just wanted to show you how much detail is preserved in the actual, this is just an imprint. This is not the actual leaf. And if we go, this is an imprint, this is the actual leaf. If you want to save any of them, these are the ones to save, and you'll see I have some up here in the, for display afterwards. But this is the one that's important, scientifically important, because that's the actual plant. And we can lift that off of the rock and look at it as a biological specimen rather than a imprint like most fossils are, or a replacement. So we can do an awful lot with this. And these are 15 million years old. That's pretty spectacular when you're talking about something that old. This is a picture of I'm going to go back in my biology. When I took biology in the 60s, there were 2 kingdoms. Now I think there are 7. and this is one of them. The fungus are one of them. This is a fungal body on a cleared bean pod that I lifted and looked at it with the microscope. These are really important, called epiphyllous fungi, and they found only today on warm temperate, barely warm temperate, but subtropical and tropical plants. These are some of the lower plants. This is Isoetes, the quillwort. These are Polypodium ferns, fertile ferns. Remember this. These are some bryophytes, and these are pieces of bark. And if you go over to the home rainforest, you'll see that there are pieces of bark fall off those maple trees over there, and there will be, and these are exactly what happens. They fall off the trees into the water and are preserved. This is an Osmundan fern, again, a subtropical to warm temperate indicator. This is a fossil fern that I found about 3 or 4 years ago. And I was telling Steve Manchester, who is a paleobotanist at the University of Florida, about it. He's got a new faculty member down there that is a fern expert. So I sent this fern to him after I removed it from the rock. This is the same specimen. And you can see these things here are fertile sori, is the term for that. And Steve took one of those and looked at it with his SEM. And this is the sori with the sporangium. A sporangium, the sori has a collection of these sporangium in it, like beans in a bean pod. And then each one of the sporangium has spores in it. And you keep going down, and here we can see the spore, and this is what's called a Trilight spore, and I still teach a course in palynology, which is a study of fossil spores and pollen. And we have these Trilight spores that are very smooth, so we know what the organism looked like that had the spore. That's really rare in paleobotany. You don't have that happen very often. This is a member of the yew family, which is the, yew is the one that Taxol was found. You're all familiar with Taxol. This is one that's found only in Asia today called Ementotaxus. It's the flower pine. That's the direct translation from the Chinese. This is a cleared leaf of that showing the stomatal apparatus. These are members of what used to be the Taxodium acae. It's been combined with the Cypress acae, which is the Cypress family, thanks to the new geneticist. Not my favorite thing to have to relearn things from my age. But this is Cunninghamia, this is Metasequoia, this is Glyptostrobus, and this is Taxodium. This is Dawn redwood, Chinese water pine, bald cypress, and this is called the Chinese fir. It's the most important tree in China. When I started my research here, I looked up Metasequoia. I will tell you a little story about that. The Metasequoia was found in a valley in China in 1943. It had been described as a fossil before it was found living. The Wallemia pine is another one that's like that now, found in Australia. That was found just about 10 years ago, I think. At any rate, before the Chinese had their revolution, the Western people went immediately to that valley in China that had the Metasequoia in it. And they did 10 by 10 meter quadrants, 10 of them. And all of those had 3 or 4 major tree types in it. And they were chestnut, sweet gum, Metasequoia, and Cunninghamia. I didn't even know what Cunninghamia was. It wasn't something I was familiar with. We'd never learned about it in the dendrology course I took at Idaho State College at the time. So I looked into it and I started looking for it. And lo and behold, I found it based on that community. So that gives credence that you can use modern communities to look at past communities and therefore look at climate associated with those past communities. This is a cleared leaf of that same Cunninghamia, and you can actually see the mesophyll in behind the stomatal apparatus. That's as good as a leaf that fell off the tree yesterday. This is a really neat slab because there's a Cunninghamia branch there, and if you go over to the University of Washington's Arboretum, you'll find Cunninghamia trees there that shed branches just like that. And this is a bald cypress. These are both metasequoia, and right up here there's a Glyptostrobus. So all members of those Taxodiaceae were growing exactly at the same time and shed their organs into the site then. That's again something you don't usually find in paleobotany. These are, this is a Callicedrus. That's the incense cedar from Northern California. Most of your pencils are made out of Callicedrus. This is the foliage that goes with it, which doesn't look anything like our Callicedrus, but it's identical to the one that grows in Formosa and in China today. This one we used to think was Abies, but it's got a short shoot here, and there's a new tree that was discovered in China during the Revolution time, and we didn't even find out about it until there was a thawing in the relationship between China and the United States. And quite frankly, Lauren can tell you that we had an old professor here, Chi Wu Wong, that had good contacts in China. And the University of Idaho was one of the first places that they visited. And the head of all education in China, probably that'd be the Secretary of Education in our situation, came here. Anyway, we had a field trip out to Clarkia to look at these things. And so this was found in 1957. And it's a member of the Abiatinae, which is the fir family of the Pinaceae subfamily. And we have the pollen and the core and the cones and the foliage of it. And they do occur on short shoots like larch. That's the pollen-bearing structure for it. This is Callicedrus, which is the Port Orford cedar, and that's Taxus the yew. These are pines, white pine, five-needle pine. There's the cone for it. There's a cone scale. It's almost identical to the sugar pine today. This is a short needle pine like a lodgepole pine, a long needle pine like a ponderosa, and that's the male cone. This is actually a seed from the Cathea, the Chinese one that was discovered in 1957. This is a cone that we found and I dissolved with hydrofluoric acid. That's a cone of a pine that has recurved tips. And there's only 4 pines in the world today that have recurved tips, and one of them is growing right in front of between the forestry building and the ag science building. And it's the Arizona white pine or Mexican white pine. This is resin that was on it. If we could get a biochemist to look at that resin, we could probably associate it with a fellow by the name of Meerhoff, wrote a volume called The Genus Pionus, and he looked at the terpenes in all of the pines in the world. And we could do that if we could get the right kind of an organic chemist to agree to do it. This is a modern one that I sort of threw in there just for an association. This is another cone that's much like the ponderosa. Now we know that the ponderosa doesn't live in the same habitat that the rest of the plants indicate, but that cone is very much like a ponderosa cone. Now we're in the diacots. This is called a wingnut, Pteracaria, and It's a member of the walnut family. You can see the similarity in the walnut. It's found only in Asia today, Eastern Asia and Western Asia. Another wingnut, Oromonia or Engelhardia, which is, again, it has a wing and a nut that's, this is the only specimen, and I found one pollen grain of it. It's got a dynastic pollen. So we were really lucky to find this. This is a pollen grain of an SEM picture of a pollen grain of the hickory, Caria. And we have no leaves of hickory or no nuts of hickory. But pollen flies in the air for a long distance. So it probably grew in the area, but not in the vicinity of the Clarkia Lake. These are magnolias. You can see this one has retained its green color. This is like the cucumber tree. This is like Magnolia virginiana, the southern magnolia. And this is the fruiting body, and a modern fruiting body for comparison. This is tulip tree, Liriodendron. I'm sorry, I hate these things. But we have the fruiting body, single seeds, a variety of different leaf shapes, just like the ones today, just exactly like the ones today. This is the Lauraceae, sassafras, lindra, which is a spice bush, and persea. The persea you're familiar with is the avocado. If you ever grow an avocado from a seed, it'll have a leaf that looks just exactly like that. The laurel family has leaves that look very similar from one end to the other, though, so it doesn't make it very diagnostic. These are vines, or we used to think they were all vines. This is a grape. This is a rose. There's the thorn for this critter here, and this is called smilax. And there's enough gray hair in here that I know you've seen Song of the South. And that was a Walt Disney movie that has been deemed inappropriate now because of some things that were in it. And it was my first encounter with a black person because I grew up in Idaho and there were no black people in this state. But it was very positive because Uncle Remus, if you all remember Uncle Remus, that was a pretty positive person to a little kid. And I think it's a tragedy that's deemed inappropriate now. Anyway, that's the greenbrier, the briar patch, that Brer Rabbit always used reverse psychology with Brer Fox and said, don't throw me in the briar patch. You could eat me, you can do anything, but don't throw me in the briar patch. That's where he lived. So, this one up here is called the Carolina Moonseed, and that's what we called it, and when I called it but Steve Manchester, a paleobotanist at Florida, has found pollen that put this in the Trochodendraceae, a very ancient line of diacots. And we know now that it is, and the name for it is called Zeuxophoides, which there is no common name because that's a brand new name. And it doesn't look like anything like Zeuxippus, is what Zeuxophoides means, but he has to call it that because of priorities. The first person that ever described it called it its genus name was Zeuxophoides. So until we find fruits attached to it, we can't give it another name. We do have the fruits, but they aren't attached. This is one of those smilax leaves that I cleared and mounted in glass. This is a really neat story here. This is a flower that I found about 3 years ago. And you can see it's got an inferior ovary, excuse me, thank you. I'm a geologist, paleobotanist, not a botanist, paleobotanist. Anyway, 5 petals, and it's got a nice stem on it. I found it, and I took a picture of it. This is the wonderful thing about these infernal machines here. I took a picture of it and emailed it to my friend in Florida. He was writing a paper on it, had just gotten the paper back, and he had all the pieces, but he didn't have a complete flower. So he was able to put that in the publication, and 30 days after I found it, it was published. So that's the nice thing about modern technology. And we still don't know what the affinity is. It's named after a Japanese paleobotanist and an Idaho amateur paleobotanist that found the ones in Idaho down in the Sucker Creek Formation. This is a reed that grows in the marshes in Asia today called Caldesia, and I have no common name for it. This is Platanus, the sycamore. And cercidiphyllum. There's about 4 trees on campus of cercidiphyllum. Cercidiphyllum is a katsura tree. There's one in front of the women's gym, there's one in front of the women's gym. There's one behind in that courtyard behind the biology building now. And they're beautiful, beautiful leaves. They turn a bright yellow in the fall, so they're nice fall colored leaves. Again, this is the first time it was found in Miocene, as many of the things we have here. Sweet gum with the fruiting body and the leaves, 3 and 5 lobed. Our sweet gum in the south are 5 and 7 lobed. The one in Asia is 5 and 3 lobed, so it's probably more like the Asian ones. Whoops. These are the birches. There's about 3 different kinds of birches. And that's an alder, and that's an alder fruiting body. This is Austria, the hop hornbeam, and that is the hop of the hop hornbeam. It's got an involucre that encloses the whole seed. This is these 2 different types of birch, and there are others that haven't been associated. That's a nice picture of an alder leaf. These are the Fagaceae, the beech family. These are, I'm sorry about that. I'll go to that's a chestnut. This is the beech, the true beech, and this is a fagus. This is if we found just the leaf, we'd call it fagus. And we found about 50 of these with the seed attached to the leaf. Again, very rare. But that seed is unlike anything in the Fagaceae, and Jack Smiley, my old major professor, wrote a paper describing that as a new genus. It's called Pseudophagus, false beech, idahoensis, and it's only found in the Clarkia area. This is black oak. These are tan oaks, but not like the tan oak in California, which has been given its own genus now, again, thanks to the new genetic work. We have only one type of oak, true oak, and that's the acorn for it, and it's a black oak that's very much like the southern red oak, Quercus pituitifolia. Willow family, poplars, willows, 2 different types of willows, and about 4 different types of poplars. This is a hodgepodge. This is the basswood, lime tree, tilia. This is hydrangea, and that's a hydrangea blossom, a sterile blossom of hydrangea. This is the horse chestnut, which is, you're all familiar with horse chestnuts, and that's an elm, and that's an evergreen elm that's a street tree in California now called Zelkova. This is a close-up of that of a flower of hydrangea. And look at the size of this. That's about 2 inches across. That would mean that snowball bush would have a flower about that big. It'd be a real horticultural specimen now. These are beans. This is the bean that I told you I had the fungus on right up here. And this is very much like the swamp honey locust, Gladitia aquatica. This is a bean pod that's a single specimen. I've never found anything like it, so we know there were at least 3 different types of legumes there. This big one goes with the big one here. The small leaves goes with the honey locust. The other one's a Chinese species I called zhenya, but it's in debate on where it really belongs. The legume specialist says it couldn't be here, and because it's an ancient line of legumes that is found only in Asia. So I'm not going to argue with the biologist. This is what used to be the Cornaceae. It's now broken into separate families. That's the only dogwood specimen that's in the whole collection, and it was here when I got here in '74. So I've never seen another one. We do have the pollen of it, however. This is the Tupelo, the mountain Tupelo and the swamp Tupelo. And one of the prettier specimens we have is this one from my place that has the irregular teeth of the swamp at Tupelo. And there's a black oak there with lots of insect damage in it. Maples, Jack Wolf, who was the USGS paleobotanist, tertiary paleobotanist, wrote a paper on Miocene maples from with a fellow from Japan, and they felt there was maybe as many as 40 species of maple in the Miocene of North America at that time. And we have many different samaras. There's 3 different kinds there, and I have another to show you. This little samara is associated with this leaf here, and that's very much like the silver maple, but the samara is like the red maple. And if you look at the breakdown of the genus acer, the silver maples and red maples are right together. So this may be something that they were both an ancestor of both of them. This is a samara you can almost lay a modern acer macrophyllum, which is the big leaf maple that grows on the west coast today. We have some animals. There's a flying ant. There's a beetle. Those beetles have the iridescent color still preserved. And I had a scholar from Ireland that was at the Peabody Museum for a while, came out to visit, and we found 10 beetles for her to look at. I told her that I'd only found maybe 20 beetles in all the time I'd been looking, but when we started looking just for beetles, we found a lot, and she was able to write a paper for the Royal Society in London on this, on the color in fossil beetles. This is another one, another kind. And you all know what that is. That's the only fossil arachnid we have found. And this is a fish. There are 3 different types of fish found out there. This is one that's, the genus now is Huco, and it's found in the rivers of Asia, many of them going into the Arctic Ocean and northern Europe. It's a salmonid. You may have seen some sporting about a big fish in Mongolia called a taimen. That's a Huco. It's one of the largest ones. And it was probably an anadromous fish. We found about 4 of these, and they're 28 inches long. And they're all the same size, which would indicate they might be like the anadromous salmon that come up the rivers today. This is what the site looks like today, or a few years ago today. And this was I did my dissertation on this site, and I counted, I cut a column 50 by 30 centimeters, which is a foot by a foot and a half, and counted over 11,000 leaves in that section from 7.58 meters to the top up here. And I put it together like a person would build a pollen diagram. I had statistically accurate numbers in macrofossils, which had never been done. And when I put it together and then associated these are all riparian species, particularly the sycamore. And it was found only in the bottom of the site. Then as we went up the line here, all of a sudden, these slope species came in. Then it's dominated in the top by Nyssa hesperia, which is the swamp Tupelo, the swamp maple, acer chenii, and bald cypress. But the important thing about this site now is associating it with where in the world today. These are what's called Pleistocene refugium. That means that if you were to be transported from right in this area in Siberia to this area in Canada, and you weren't a botanist, you wouldn't know you'd gone anywhere, because the same genera of trees are in that. It's called the boreal forest, and it's circumpolar. Birch, aspen, firs, pines, and larch, and it's almost the same composition. 15 million years ago, this area was covered with this very rich, maybe 100 different species of plants, trees, and then came the Pleistocene. And it pushed all of this flora down into areas that were protected. There's a mountain range that's transverse here in China that protected central China from those cold Pleistocene winds. There's a little area in the Caucasus Mountains that was a barrier to the cold winds coming off of this ice cap here. And there's a little valley in western Turkey that has some of these remnants in it. And the mountains, the old mountains in Central America, those became refugiums at the time. They're called cloud forests now, not on any of the new volcanoes down there, just the old mountains. And along the west side of the Sierra Nevada and along the Pacific coast, these are Pleistocene refugiums, where we can find these same genera of plants that we find in the fossils at Clarkia. The best one, however, is this one right here. And in and around the Metasequoia Valley, that valley I told you about, 65% of the genera that we find at Clarkia are found living today. So we can look at the climate there, and the climate there is, this is a very poor slide, I apologize, but that's about 74 degrees maximum July monthly temperature. And the one down here is about 35 degrees for January. And the annual rainfall is about 50 centimeters a year. That's not a lot different than out there right now. We have 38 centimeters a year at Clarkia now. So using this, I have a friend named George Grader. Some of you may know George. He's very good, but his slides are very detailed. And he had this slide in a study he was doing for the sediments around Clarkia. And there's an awful lot of information on that. What I want you to notice is this right here, the Miocene climatic optimum. And that is a very warm period of time. The people at WSU are studying how much carbon dioxide was put off by this Grandron and Imnaha basalt right now, and coming up with a lot of carbon dioxide. And it may be a past analog for where we're headed if global warming is going to continue. I'm quite worried that the Milankovitch cycles have always said that we're going into another glaciation. And if you think global warming is a problem, try global cooling. It's a lot bigger problem. Canada was covered with an ice sheet right down to the Canadian-US border for most of those glaciations. Anyway, this is the oxygen isotope data here that show the... So I'm working with some people at the University of Washington now that we're going to put together a big grant proposal to study this period. These are the people that have helped me throughout my life. Jack Smiley, I learned a lot of paleobotany from this man. Janine Shreve supported me in many, many ways and actually saved the collection. We had a dean of the College of Mines that was going to dump the whole thing when Jack died. In fact, the day he died, he gave the order to dump all those fossils over the bank. And if Janine hadn't have intervened and taken that space away from him, there would have been a lot of things gone wrong. So, Ken Sprinky and Gene Bobeck introduced me to these infernal machines, and that's why I'm talking with you today, or I'd have just given up on it. And George Grader has always been he was a grad student here and has a very good geologic mind, thinks outside the box on a lot of things, and is wonderful. And thank you very much, and I'll be glad to answer questions. Yes?
Well, that was really fascinating. Why the connection with Asia?
Well, like I said, that whole boreal forest was a mixed mesophytic forest for many, many years until the glaciation pushed it down. So that boreal forest had similar, and we see that in the records in Siberia and Japan. All of those have Miocene floras that are very identical to the ones at Clarkia. Europe is the same way. I work with a guy in the Czech Republic that came over here. Europe is spending, for the last 20 years, they've spent a terrific amount of money studying the mid-Miocene climatic optimum. And they're looking at it from pollen, and the resolution you get in pollen is terrible compared to macrofossils. And we have this wonderful macrofossil. And in addition to that, we have sites that are associated with those older basalts. In fact, one of the fossils I have here, you recognize this? That's a ginkgo leaf. There are no ginkgo leaves at Clarkia, but there is ginkgo leaves at Muscle Shell, which is down near out west or east of Orfino. And we can compare what happened with that flora, earlier flora to the later flora as the carbon dioxide content grew. Yes?
Bill, it seems like it's been a really unusual depositional environment. It's almost like the leaves aren't deformed at all. It's like they've been put in a plant press. So you had like almost no current flow, but at the same time, enough sediment coming in to press them all down.
It's an amazing site. There's a term for special fossil sites called Lagerstätten. And we teach paleontology out of a book that was printed in Britain and written by a Brit and a Dane. And they list 36 Lagerstätten in the world, and this site is listed as one of them. So this is one of the 36 best sites in the world based on what their opinion. And that is because the conditions were just as you said. It was a very narrow, very deep lake instantly. And anything that fell down below that zone where there was no oxygen was preserved. And the colors are still there. I have a block of material I cut out yesterday, and I'll split that open, and hopefully we can see some of the color still in the fossil. It'll turn black in front of your eyes. But we can study these as a biological specimen, which is really rare for something 15 million years old. And it was covered up, and quite frankly, this whole area has not been affected by mountain building at all in the last 15 million years. It may have come up, but it hasn't been twisted and pushed and metamorphosed. That's what really raises heck with fossils. And if you go down to Whitebird, you can find fossils that are very similar to these, but they're in rock, and they've dried out. This area has probably remained wet for the last 15 million years because the Rocky Mountain spine has been there all that time. And the Hoodoo Mountains are another range that have been there quite a while. That's the range between here and Clarkia that go from Clarkia down to, to Plummer, if you want to extend it out there. You go over it on White Pine Drive. Bill?
I want to ask you about your fish.
Yeah.
You suggested that they be salmon.
Well, anadromous. But
what does that mean? Does that mean
anadromous means it goes to the ocean and lives and comes back and spawns. And
that's what I thought you said, so I'm very interested in the connection to the ocean. So as the salts come out, wouldn't they have disrupted all the drainages, the Colloquium River, the Snake, all been filled? So what are you talking about? Where would the connection with the ocean be?
Well, if you read the people that work on the basalt, they felt that the Snake River follows the same course it did prior to that. Now, there's a paper that puts a snake going out through the Blue Mountains right down on, Steve Rydell gave a presentation on that over at WSU here last year, I believe it was, or 2 years ago maybe. The Salmon River went out the Snake River went out that way, and the Salmon River continued where the Snake River is now. That's the way it went. So I don't know. That's a good question. But when you find 4 fish that are all exactly the same size, that would suggest to you, like if you see sockeye salmon. I grew up in Stanley, and sockeye used to spawn in Redfish Lake, and they were all about the same size, and they are in Alaska today too. They vary a little bit, but these are all, and that's my estimation, and I'm certainly not a fossil ichthyologist. Anybody else?
So, Bill, for folks who haven't actually been out to the site, could you describe the process of excavation and then separating the leaves and then preserving them for display?
Well, you can see it's very soft material, and these are specimens. And if you look at these, I don't want you to, it's everybody wants to put their finger on them. And we don't put our fingers on any of these. I tell people that come out and collect. And by the way, if anybody wants to come out and visit my site, they're welcome to. Just get a hold of me ahead of time, and you're welcome to come out and collect. And you can collect there. There's dozens and dozens of fossils, as you will see here presently. I will demonstrate how I do this. Now, once I get a fossil that I lift, I use hydrofluoric acid to remove them. Hydrofluoric acid is one of the worst acids in the world. Many universities won't even allow it on campus anymore. But Janine Shreve is a fluorine chemist, and that's how I got to know Janine, actually. I gave a presentation on she couldn't believe a geologist would use hydrofluoric acid because her chemists don't even want to use hydrofluoric acid. So anyway, I tell people it hasn't hurt me, but they say, yeah, you're Exhibit A.
You mentioned that there was also a site in Pullman. Do you know where in Pullman?
Well, they built a new road up past the water treatment plant there. And the Rosa flow of the Wanapum Formation, that's as far as it went. And that, there's sediments associated with that. When they made the new road, it's all grown over now. I tried to find it a couple of years ago and I wasn't able to find it. I do have some specimens from it when it was first opened up. These materials are very, very soft. It's clay. So it deteriorates with weather very fast. So I have to be there when the road is opened, or the gravel pit in the case of the one at Muscle Shell.
Well, if there are no other questions, maybe it's time to get a little closer to Bill for a little show and tell, and he'll open one of these blocks of clay and we can see some 15-million-year-old leaves in their original colors before they oxidize. You're welcome to stick around and talk informally, but let's thank Bill for